final presentation of the evening is Denis Grey, who's going to be talking about upgrade options for Schmidt Cassigrain telescopes. Denis?
Hi, Tom. Thanks very much. Good to be with us all again. I'm just pleased to be with you with this presentation. I had planned to deliver it last month. I ran into some troubles getting it together. I wanted to actually show how things were being put together and how they were being assembled. So I felt that was a good opportunity to bring out one of my classic presentations. So we went and visited the Texas Star Party. Now I'll give you the presentation that I had planned to give originally. So in terms of that essential review, I wanted to first of all talk about my particular Schmidt Cassigrain telescope, where it fits into the world of Schmidt Cassigrain telescopes. I'm going to talk about two specific upgrades, the Fast Star Hyperstar upgrade and also the new dew heater ring from Celeston. So hopefully one or both of these items will pique the interest of our Schmidt Cassigrain owners out there. So first, sort of a little background on my SCT. This was my first quote-unquote real telescope that I acquired. I had bought a Bosch & Lomb 4000, which is also a Schmidt Cassigrain telescope. However, few shall speak its name. It was a terrible Comet Hunter telescope made in the 80s around the time of the Halley's Comet thing. And it didn't really have good optics or anything, but it was a nice introduction to the hobby. So the first real telescope I bought was in around 1993, and I was originally part of an 8-inch Ultima system, which was the astrophotography scope of the day. It was a very good Schmidt Cassigrain crown glass, well figured. Because it was being sold as part to the photography market, it had generally really good optics. And so when I realized that the Schmidt Cassigrain, the fork mount wasn't working out for me, I wanted to keep that scope, so I dismounted it and converted it for occultation use. And it's now mounted on a much lighter, more portable GP mount that runs with EQ mod. So it's got a go-to mount that's able to be picked up and moved as we want to go. Now the use cases for this scope are kind of twofold. One is casual observing. It's still a perfectly good telescope, so I can put it on any reasonable mount, and I can use it either in f10 or with the, I have a f6.3 focal reducer, so I can use it visually for that. These scopes have a 1.25-inch opening in the visual back at the back, but you can work it with a 2-inch eyepiece, so it works as a visual instrument, but its main use these days is for occultation recording. So as many of you know, I'm interested in occultation, recording asteroid occultations and doing some data analysis. I haven't had very much luck over the past 5 or 7 years, but it hasn't stopped me from trying. So what we want for occultation recording is the ability to go deep and capture faint stars, because there are way more events available to record if you go below 10th magnitude or 11th magnitude than if you have to stay up at 6th or 7th or 8th magnitude. You want it to be portable enough so that you can go remote, because sometimes occultations you have to go to them rather than them coming to you. And it also needs to be photographically fast enough so that you can, when you're recording with the camera on the scope, that you're getting a high enough frame rate per second that you can actually get some useful data. So being able to pull in a star at a rate of 4 seconds per exposure, that's probably okay if you're trying to take a picture. But if you're trying to say when did this star get occulted or not, it's just too granular a level for it. So that was an important consideration as well. So the answer to that is in part something called Fast Star. Now, Fast Star is an interesting sort of configuration. It's only offered by Celeston. It's not something that's offered by Meade and their Schmidt Cassigrain telescopes. And if you look at a sort of a standard Schmidt Cassigrain telescope configuration, the light comes in from the front, going through a very lightly figured corrector lens, which corrects for some aberrations, hits the mirror at the back, hits another mirror at the top of the tube, which is a little round mirror in the middle of the telescope. And you'll see that kind of mirror also on Maksutov Cassigrain telescopes as well. And then finally, that light goes all the way out, goes through the end of the telescope, and then either hits your eye or hits the diagonal, depending. So essentially, this is a two reflection model, 1, 2, boing, boing, before it hits you. And that's a fairly slow configuration in terms of its setup. And the reason we do this, of course, is to reduce the total length of the telescope. You could do the same thing if the telescope was 3 times larger, and then you would basically have a Newtonian reflector type of telescope. But that would make it much larger and harder to carry around, harder to mount, and so forth. That's why Schmidt-Cassigrains became very popular when they were introduced. Now, the fast star system essentially removes that secondary mirror. It completely, you take that mirror out of the Schmidt-Cassigrain telescope, leaving you with just one reflection. So it comes in through the corrector lens, hits one mirror, comes back up here, and then it goes through a fast star lens, which sorts it out and flattens it, and then presents it to the camera, which is going to be up here, roughly where my cursor is. See it up there? That's where the camera goes. So the end of the telescope is not used. So where you would normally put a diagonal or an eye, you just don't even use that at all, and all of the business happens at the front of the telescope. That's the nature of the fast star system. Now, where this comes in, how this impacts occultations is tremendous benefit for me, in the sense that the field of view that you get from the same telescope without changing the telescope is basically going from this small box, which is basically just big enough to capture the trapezium in the middle of M42, to being able to capture almost the entire sword of Orion. All of the nebulosity and so forth there can be brought in with the same camera on the same telescope just by using this lens and changing it up. So the field of view goes from 0.3 degrees up to by 0.2 up to 1.5 to 0.95. It's almost 23 times larger in terms of the viewing area, which is fantastic, because one of the troubling things we have with trying to catch occultations is that sometimes it's very difficult to find the right field. You know, you're looking through a field of stars, your go-to system isn't quite accurate, you're setting up on the fly, you're in a hurry. It's really helpful to be able to find, use more stars to track the location of the occultation and zero in on that particular star that you want to try and record. Now, there is another thing called hyperstar, which is part of the quote-unquote fast star story, but it's not quite the same thing. So fast star and a fast star lens was the original generation lens that was designed to work with the S-big camera of the day. This was introduced around 1995, and it essentially was working with an S-big camera at the time, which was basically like a 640 by 480 field of view camera, and it was optimized for that kind of camera. So it's very small field of view, but it introduced the fast star system, and you can still buy that on the used market. But the one that's sort of in use today is the one that's called Hyperstar. Now, Hyperstar, essentially what happened here was Celeston wasn't happy with how well these things were selling, and a company called Starzona out of Phoenix came to them and said, well, we'd like to license the technology from you and do our own thing. And what they've done is they've created something they call Hyperstar. And Hyperstar is basically a next-gen version of this. It's got a larger field of view. It's designed to work with larger cameras, even DSLRs. And it includes collimation screws to align the field, and it's got a nice protective case that you're able to put the secondary mirror into and so forth. So I've only been using the Hyperstar, but I do understand that the old fast star is still there. So what is it you're buying? What is it you're getting? So essentially, you have on the bottom of the Hyperstar lens assembly, you have a thread that's designed to screw into the front of your Schmidt-Cassigrain telescope. So when you take your mirror out, you're left with a little threaded ring there where the mirror used to be, and the lens bottom screws straight into that. The top part of the lens here is where you put your camera. So that is a standard, what's called an M42 thread. And the M42 thread works with all kinds of different adapters to connect various kinds of cameras. In my case, I'm able to thread directly onto the Hyperstar with my camera. But if I was using a DSLR, if I just had a T-ring, I could put the T-ring on this Hyperstar and snap the camera into it, and it would work. And then the other thing that comes with it is there's these collimation screws. They're a combination of push and pull. So if you're working with your Hyperstar and you want to really, and you find your field isn't flat, you've got some stars out of whack in this corner and other stars that are there, you can adjust the field of view. And because even though it's a round system, when you screw it into place, it always tends to lock in the same location. So if you adjust those collimation screws for a specific telescope, it should continue to work that way as you go forward. So very well made piece of kit, fairly high quality, hefty, made of aluminum and other good materials, and about $1,000 or so to purchase one of these. So sorry, that's the bad news in this presentation. If I was getting you excited, maybe I've just unexcited you. So how do you go about installing it? It sounds kind of scary. You're putting this thing in the front of your telescope. Well, it does look scary, but it's actually not that bad. So you start with your Schmidt Cassigrain telescope. There's a retaining ring, which is the surface that's used to maintain keep the secondary mirror in place. So you don't just gently unscrew that with your hand. There is a little tiny knob on the back of the secondary mirror, and you simply lift the secondary mirror out, as I've done here in step 2. Then you can see that's the mirrored surface there. You take that and immediately plop it into the Hyperstar case to keep the mirror clean and keep dust off of it. And as soon as you've done that, then you're ready to actually put the Hyperstar in. So then the Hyperstar assembly is dropped in and screwed in place of the where the secondary mirror used to go. And then the final step is that you add the camera. And in this case, I just screw the camera onto the lens, and then I get this configuration here with my Hyperstar connected to the correcting plate. So I've got my correcting plate, I've got my fast star interface, the Hyperstar there, and the camera there. And all I need to do now is to connect my camera to my computer, and I'm ready to start work with my Hyperstar. So overall, this has been a real improvement in terms of what I'm able to do for occultation work. I did notice it's kind of cool though that you have this gear that you're able to stick on the top of your instrument there. But the results that I'm seeing are pretty good here. So this is a frame from an occultation attempt that I did in April. The attempt was a success. The asteroid chose not to show up. But what you can see here is, first of all, I'm getting a pretty wide field of view here, and also how deep I'm able to go. So I'm able to clearly see 10.6, 10.8 magnitude stars here in this field, and I think I could probably convince myself that I could even go a little fainter than that. And this is 1/8 of a second exposure with appropriate gain settings and so forth on my camera. So I'm really pleased with how well that's working and how well it's able to help me get to that level. So with some confidence in knowing that I can get to 10.8 magnitude, that allows me to expand my available search space for occultation opportunities, which hopefully will allow me to actually have a successful one someday and start getting some science and spending less time on the equipment. But while we wait for that to happen, we spend time on the equipment. So one thing I should mention as well is that there are improvements coming and have been coming through Starizona to this particular technology. So the one I have is the version 3, which is designed to work with an 8-inch Cassigrain that runs at f2.1 for photography folks there, reducing my 2,000 millimeter telescope down to 425 millimeter focal length with a large image circle and a maximum field of view of 3.8 degrees. So there is a version 4 out now, which is the one they're selling, which is f1.9, takes the focal length down even further and increases the field of view significantly as well. So it's good to see that even though this is something I would consider to be sort of a niche product in the sense that not everyone's going to want to spend $1,000 for this particular combination of telescope and telescope equipment, it's good to see that the manufacturer is still supporting it, still making new versions, and that's encouraging. There's a lot of opportunities in the aftermarket for Schmidt Cassigrain telescopes. They're one of the most popular models in the world, so this is one reason why this accessory kind of exists, if you put it that way. So this is, I'm just going to pause for a moment because I'm going to move on to another topic now and just see if there are any quick questions before we move on to the next topic in my presentation.
And Emma, are there any questions?
We got a couple of comments and one question. Eric Briggs says, I hope I can do another asteroid occultation soon, and that I've been using FastStar for almost 20 years. It's very good, but it's time for an upgrade.
Cool. Good for you, Eric. If you want to give, if you're in Toronto and you want to come by and have a look at it, you're welcome to.
Eric also asks, he says, congratulations, Dennis. Was this a successful miss?
It was a successful miss. I got on station. I found the right star. I confirmed the right star. I had everything up and running. I even had 30 minutes to make tea. It was good. It was a good one. It was a very low probability, though. It was like one of these ones. It's like I was not at all surprised that it was a miss because I think I had about a 5% chance. But if I had found it, wouldn't that have been awesome?
That's great. We actually got a couple more questions that just came in. Chris Vaughn wants to know, how do you collimate?
You're basically looking at your field, and you're looking for, if I go back here, you're looking for problems in the edges of the field here. So if you took a longer exposure and if you saw that things were sort of smooshed out that way and that things were starting to become comet-like when they weren't comets, then you could adjust it there and take some additional exposures. So I think it's an iterative kind of process. You can try collimation tools as well. I think that would work, and they are supposed to work with FastStar as well. But that would probably be the kind of collimation one would want to do. Hope that answered the question. I haven't had a chance to do it myself.
Yes, great, thank you. This next question comes in from Eric Briggs. Thuringia? I don't know what that means, but that's what he wrote.
Is that a question about which occultation it was?
Oh, possibly.
It was UB244, I think. I'd have to look it up, but yeah, it was reasonably bright star at 11 o'clock at night. It was pretty good as these things go. All right, I'm just going to carry on then. We'll get more questions at the end. And I'm just showing here the tool case that the whole kit and caboodle fits into. And the Hyperstar, I have a plastic case that I put the whole thing into, and it just tucks right into the tool case beside the SCT, creating a nice compact and very portable system for me there. All right, the other thing I wanted to tell you about was dew heater rings for Schmidt Cassigrain telescopes. So, for those of you who are kind of new, dew control is something that astronomers are often very, very interested in. Often the best nights for observing often have the attribute where there's high humidity, and when the temperature drops at night, you can get dew forming on everything, including on your optics. And as soon as that happens, your observing session is basically toast because everything goes blurry and out of focus, and that's very hard to recover from. So there's two major ways of dealing with this. One is to essentially take out a hairdryer and blast your telescope. That's not easy to do, and you need a power source for the hairdryer and yada, yada, yada. Or to work with dew heater strips. So dew heater strips are usually Velcro strips that are wrapped around certain parts of your kit, and you apply some power to those strips to heat them up just enough to prevent dew formation while not affecting your observing. So you don't make them super hot because you don't want them to overheat, but you often have a dew controller which has sort of temperature and dew point sensors which turns them on at the right time and tries to make sure that the optics are kept just warm enough that the dew will go somewhere else, basically. So when everything's working properly and you are using the dew control system, your optics will stay dew-free. The telescope itself and you may get wet, but the telescope and its optics stay free, and that's the goal. Now, dew heater straps have been sort of the gold standard in this industry forever and ever. They were popularized back in the early 80s by Jim Kendrick of Kendrick Astro Instruments. And Jim basically took this design, which had been talked about by amateurs for years, which is basically putting a series of resistors into a Velcro or into a strap and then using Velcro to attach it. And he basically turned it into a commercial product. It uses an RCA style plug for the the power connection, and that's become a universal standard that's used all over the world. And he's still out there, still making them. You can still buy his dew heating products, and I recommend them for a lot of different uses. So certainly that has been the way that it's been going. However, there's a new thing on the market, which is a dew heater ring. So as opposed to the strap that you would use for a Schmidt Cassigrain telescope, it's about 26 inches long and has to be wrapped around to get the whole thing, and it can get caught on other equipment and so forth. Celestron's introduced these dew heater rings, which are precisely designed to fit into their SCTs, 5, 6, 8, 9 and a quarter, 11 and 14 inch, all available. And the heat is applied directly to the corrector plate in front of the Schmidt Cassigrain telescope instead of through the telescope from the outside. So when you're putting a dew strap around a Schmidt Cassigrain, the strap goes around the outside as close to the corrector plate as you can get it, and it's supposed to warm it up just directly through there and then transfer to the glass. And so it's not super duper efficient, but these dew heater rings actually go straight onto the corrector plate and actually replace the original ring that's there. So this is a picture of one of them here, and you can see essentially we have the plastic ring, which is the actual replacement ring for the telescope, and then there's just this little brown or yellow band, that's the heating strip that goes around the ring there. That's what you're getting. And it's using the same RCA standard plug that all dew heating equipment uses. And it also includes an optional cable, which is designed to work with a proprietary Celestron dew controller. So Celestron's also offering, in addition to the dew heating rings, a proprietary dew heating controller, which is advertised as sending just enough heat to the dew heating ring to keep your optics clean. So that's the kit, and both parts are sold separately. So in terms of the installation, it went pretty well with one glaring exception. So the first step was to remove the retaining ring, so that came off fairly easily. They provided this nice white sheet of paper to help protect your optics while you're working on removing the ring, and I felt that was quite appreciated. Then you align it with the mounting holes, and then you can see here I'm using a fine Allen key to reinsert the screws and put the new heating ring in place. Now there is a problem I ran into during the installation, which is that, and this is actually on the Celestron website, which basically says that the older models of their Schmidt Cassigrain telescopes are not compatible with this system. I wish I had read that before I bought it. However, I did not, so I carried on as well as I could. But if you have an older style of Schmidt Cassigrain telescope like this one, with that aluminum handle at the bottom, or this even older style, which is the ribbed one, which is the cast aluminum bottom, they are supposedly not compatible with this system. So buyer beware there if you have an older Schmidt Cassigrain like me. So my experience was, I tried it, and the mounting holes aligned perfectly well, no problem with the installation. But the issue that actually I encountered was this area here where the wires go into the ring. they kind of stick up and they hug the edge of the telescope tube very tightly, which effectively prevented the telescope cover, or the cover for that, from fitting over those cables. That was the issue that I ran into. So it wasn't that I couldn't install the dew heating ring. I could. It wasn't a problem. The problem was putting my telescope cover back on once those rings were there because of these things sticking out. So I basically, my guy decided, okay, I'm going to be bold here and I'm going to cut some holes. So I marked the area that was having the problem, which was about 6 inches of diameter, or not diameter, circumference, had that particular problem. And I basically trimmed the telescope cover to fit. So you can see here I've cut out the edge of the telescope cover just enough to allow it to bypass or to sit on top of those wires and the wire attachment points there. And when I did that, the telescope cover fit very nicely. So I was pretty pleased with it. So the installation, when it's complete, looks like this. There is this little dingus that is included with, which allows you to sort of pull your cables out of and bring them back away from your telescope. And when you're working with putting a dew cap on it, that will make sure that is there. That's kind of optional. You don't have to use that, but that is an option that's available to you when you're working. Okay. So hopefully that made sense to everybody. We can go back over these pictures if there's questions. There we go. And then this is just a final picture here of the installed items. So I'm ignoring here the control cable. This cable is the cable for the Celeston proprietary controller. This is the one that's going to my RCA plug, so it's ready to go. And as a bonus, I got an upgrade on my telescope. I got new Starbright XLT coatings, which I thought was pretty cool. And that's that story. So it's nice, elegant. I was able to install it despite the fact that my telescope was a bit too old, and I enjoy having one less thing to worry about when I'm in the field in terms of getting set up quickly. And this is, as I said, available for all popular sizes of Celeston SCT. So there you go. That's my second part of my presentation.
Sounds great, Dennis. Looks wonderful. Emma, any more questions for Dennis?
Yes. So this first question is about the first presentation. It comes in from Leo2CAF. Can you use other cameras with it?
Yes. Basically, anything that will fit on an M42 thread, or you can adapt to an M42 thread, can go on. So my particular camera there is just one camera that I could have used. I've seen people use it with DSLRs. I've seen people use it with other cameras like S-Big and so on. Obviously, because you have the camera in the way, you want the profile of the camera to be smaller if you can, just so that you're not obstructing the SCT's light path too much. But I find for occultation work, it's a nice trade-off. The camera I have, it's a little bit bigger, just a tiny bit bigger than the central obstruction, so I'm kind of getting a little less light throughput, but it mostly doesn't get in the way.
Great. This next question is also about the first presentation. Do you use any LP filters with the Hyperstar?
Not at the moment, but there are filter drawers and filter accessories one could add. So I could put a filter wheel or a filter or a single filter in that light path between the camera and the fast star and just refocus it if I wanted to. But for occultation work, that's not really required. I'm just doing black and white kind of work. But if I wanted to get into that, I could certainly do it.
Sorry, they also wanted to know, does that cause any aberrations due to a fast optical train?
I don't know. Again, like because I'm recording these for winking in and winking out, kinds of things. I mean, it looks to me as though I would get good pictures from it if I wanted to take good pictures with it, but that would be more effort. I should try it and give it a whirl and maybe report back. But up until now, all of my exposures have been ideally less than a second. So I haven't been trying to stack them or do any kind of post processing on them. So I can't really comment too much more than that.
Okay, thank you. This next question is, shouldn't Celeston, it's about the second presentation, by the way.
Mm-hmm.
Shouldn't Celeston consider adding these dew heating rings as a standard part of the new SCT scopes they sell?
One would think. It really is something that does make one a little nervous in the sense of doing this stuff could be done at the factory, I think. I mean, on the one hand, I can see that it's an aftermarket thing because there's just, tens of thousands of these telescopes floating around, and people will want to upgrade them. And it's also the kind of thing that, you could easily have installed by your local telescope store if you're not comfortable doing it. But yeah, I mean, I think dew heating, like some higher end telescopes, like obsession telescopes and so on, they include heaters in basically at the factory. The heating element is included, and you just have to plug in a heating controller into the telescope, and then the key mirrors and things are kept appropriately heated. It just feels to me like I agree. It should probably be included. I mean, somebody who is observing in Arizona might say, "Well, I don't need that because I don't have any dew in Arizona." But for most of us, it is a problem. And the reason that I think there's a market for it is that all of us have been out at a really great place like Mew Lake in September, and we think we're having a wonderful night, and then the dew closes in on you, and you have everything set up, and you have a beautiful dark sky, and everything's going well, and you can't do a darn thing. And I've had that happen to me, and it's just the worst feeling because once the dew sets in, and if you can't stop it, you're done. There's nothing you can do really.
Okay. Lastly, we have a comment coming in from Eric Briggs, who says, "I'm not sure that's how Starbright XLT works."
Thank you for catching my little joke there, Eric. Much appreciated.
Great. Well, that's it from questions and comments.
All right. Excellent. Thank you.
Wonderful.